series of theory of computation lectures, we will see the construction of finite automata. In that, when we are constructing a finite automata, we have a problem statement here. Design finite automata with sigma, that is over the set 0, 1, the star accepts even number of zeros and even number of ones. Okay, please note down the terms even number of zeros and even number of ones. You also note the keyword and. Okay, so the string should be, the finite automata should accept only the even number of zeros and even number of ones. Okay, so this is the mathematical notation for that. So first one is number of 0, the length of number of 0 is congruent to 0 mod 2. So otherwise you can say the number of zeros of the string mod 2 is equal to 0, which means it is divided by 2. So number of ones mod 2, that is, it is a even number. So even number of zeros and even number of ones, this is the meaning of these mathematical notation. So you can write this congruent statement into that way. Okay, so even in the problem statement you may get question for, like they can give the mathematical notation and ask you to find the number of states or find the finite automata. So in that case we have to follow this technique. The first one, always we have to find out what are all the members of the language. Okay, so this is a member. The first member is epsilon. So whenever we say even number of zeros, so here 0 mod 2 will get 0 mod 2 will get 0, right? So which means the epsilon will be a member of this language. And then 0 0, only 0 0 may be a string of that is member of that language, or otherwise I can have 1 1. Okay, so otherwise I can have 0 0 1 1, right? So even number of zeros and even number of ones, right? 0 0 1, or you can make it as like when you're seeing the string, the even number, when you're counting the length, counting the zeros and ones, that should be even, right? So here 0 0 1 1 1 1 0 0 0 1 1, likewise it goes on. So you can also have like 0 0 0 0 1 1 1. I will not take 3 zeros 3 1, 4 zeros or 4 1, there you will have combination. So which means the set is the infinite set. Okay, so the language is the infinite language, infinite set. Okay, so first of all they are asking to construct a finite automata for even number of zeros and even number of ones, right? So first of all we have to concentrate on only even number of zeros. Okay, and separately just divide the terms. First you construct the automata for even number of zeros, and then construct automata for even number of ones. Then you just combine those things, combine two diagram, and you will get the answer for even number of zeros and even number of ones. Okay, first of all, counting zeros, we have to count the zeros. So we have to check the even number of zeros, right? So we all know even number of zeros in the sense, so we'll have always epsilon will be a member. So I will have the starting state as the final state, and then this denotes the way. In the previous lecture we were saying that this is even state, this is odd state. So when I receive 0, even number of 0, this will receive even number of zeros, right? So I cannot make here 1, right? So I can make only zeros. So a to one state to another state we are giving input as 0, that becomes like even number. Just finite state will accept, final state will accept only even number of zeros. Here you will get only odd number of zeros, right? So this is the diagram for the counting zeros, that is even number of zeros. Okay, here counting ones in the sense, what we have done, we have made this state as a final state, but then we have changed this string. We have to count, we have to concentrate on ones. So we are giving the input as 1, and we'll get even number of ones here, even number of ones here. So here you will have even number of ones here, you will get even number of ones. Okay, here this state will receive only odd number of ones. Okay, odd number of ones. This is what the two separate diagram. So what you have to do is we have to cross multiply, we have to take cross product. Here you have two states, here also you have two states. So just to do the cross multiplication, so a comma b are the two states here, c comma d are the two states. So just to cross multiply this, we will get ac and then ad and then bc and bd, right? So you are getting 4 states. 2 cross 2, you are getting 4 states. So now when you are combining these statements, even number of zeros and even number of ones, you just take the states, 4 states. First one is AC, second one is AD, and then BC, BD. Just you have already have the transition here. Just to take this transition and here you just fill it. So first of all you consider the state A. So from A to B you are giving input 0, right? When we are reading 0 on A, it goes to B. So just making this transition, okay, 0. And then when you have self loop here, okay, when you are reading 1 on B state A, it remains in the same state, right? So we have A here, just we are making this transition, okay. And then you have B, self transition is here. B to B you have 1, okay, B to B you have 1, and then B to A you have 0. So when you are giving 0 on the state B, it goes to A. So which means B to A. So this is the transition, right? This is the transition. B to A, you are giving the 0, okay. And then here you just see the transition and just connect it. So C, so when I'm giving 0 on state C, it remains C. So it remains in same state. So C to C we are giving we have already filled this transition, just leave it. C to D you have 1. So C to D you have already filled it, and D to C you have 1. So D to this transition will come, D to C you have 1, and then D, when you are reading 0 on state D, it goes to same state. So D to D you have 0, and then A to B. So here A to B we are having 0, right? So here here also you have 0, right? So likewise, and then also you are having B to D, C to D you are having C to D you are having 1, right? So again C to D and A to A, right? So this is the given. This is the we have formed we have separated the statement, and then we have formed the automata, and we are just combining using the cross product method, and we are getting the finite automata here. So here this is the starting state. Now we just see, so they are asking to build the finite automata which accepts even number of zeros and even number of ones. So here this state will become the final state, okay. If they are asking even number of zeros or even number of ones, means what you will say, even number of zeros or even number of ones, in the sense you will have these either or, this one, all will become the final state, right? But now, as of now, this will not be a final state, only this case, this AC will be a final state, okay. So this is the note you have to make it, that is zeros and ones. So when is even number of zeros and even number of ones, final state will be even. So whichever is accepting even number of zeros, even number of ones, that will become the final state. So when I say or, I can have either or, right? Even, odd, even, or even I have both even. So these three will become a not final state, okay. I hope you understood the concept. If you have any doubt, please comment on the comment box, okay. Thank you.